my presentation will be maybe a little bit more general than the next two speakers. And it's focused on water, energy, and the relationship with land, because that's my area of focus. So just to start off this presentation, the picture over here is from Australia, and it's a gully that was created in the soil by water. So it's the sheer energy of water that created that type of land degradation. So there's a little bit of a water could be the energy that degrades land, but my presentation won't quite focus on this aspect, but rather the reciprocal relationship between water and energy that can be used as inputs to land, and that can be also derived from land. So what I mean is that you can have a piece of agricultural land, such as the one in the picture. This is from Rwanda. It's fairly wet because it's in a very humid area, and this was taken during the rain season. And you've got energy and water that are necessary to cultivate land. So energy could be in the form of fertilizer, in the form of labor, or in the form of machinery. Not so much in this particular context in terms of machinery. You also need water, either rainwater or irrigation, so that you can grow crops. And these are what you put into your land, and then what you get out of it would be food and biofuel, for instance. So that would be a form of energy, either for human beings or to put in your car. And also the land provides some regulation of the water quantity that's around. So it could help mitigate droughts or floods, or even the adverse impacts of landslides. It also regulates land quality by providing natural water filtration. So as you can see, it's not such an easy relationship. It's energy and water, things that we put into our land, but we also get some back. And there's potential trade-offs in terms of what we get out, for instance, because there's only a limited amount of land available. So you can have a trade-off between food security and energy security. So how much food do you produce versus biofuel? In 2007, 2008, there was what was called a food crisis. This was a major shortage of agricultural outputs in these years compared to normal. The prices of agricultural commodities went up, which had drastic consequences for people trying to feed themselves, especially in developing countries. So you had the tortilla wars in Mexico and a few others. And this was partly because of bad weather conditions, or a combination of different climatic events that led to a reduction in agricultural production, but also partly because some of the land was dedicated to biofuel production, so crops that were cultivated to then produce biofuel rather than food. So because of that, it took some land out of agricultural production, and sometimes you might have to choose between what you want out of your land. You also can have a trade-off between food security and water security. Because if you cultivate your land too intensely, you can compact your soil, which will lead to a reduction in water seepage through your land, and the reduction of the natural water filtration and water quantity regulation. So that could lead to landslides and different floods. So that's some of the choices that we have to make, because there's only so much land available and we can't do everything. There are also different synergies that we can get. It's mostly focusing on the inputs to land, so we can try and target different production systems that will allow us to get multiple outputs for a set combination of inputs. And that will be detailed a little bit more by the next two presentations. So you can use technologies like biogas to produce fertilizer, to improve sanitation if you combine it with latrines, and you can also produce energy from it. So it's a slightly different process. And you can also use drip irrigation, so you use less water to produce 1 kilogram of crop. So you've got a diversity of available technologies and setup that can be used. Which leads to the choice of the most appropriate option. How do we choose? And again, this depends on the range of factors, because it has to be technically feasible within a certain geographical area, for certain climatic conditions and for a certain type of soil. It has to be financially and from a socio-economic point of view viable, because people have to make a living out of this land. I mean, you can't just ask them to do things without, if they're really poor people already, it's difficult to tell them to reduce their income if they're already struggling. You might have some political factors involved, and sometimes you need to work at the political level, either the local political level up to the national or international level. You can have some legal factors, so the property rights settings may favor different options. If you've got the private property set up that is well informed and well regulated, it might be easier to enforce some of the options compared to a common property rights system where everyone shares a piece of land and has to agree with one another on the best way to use it. There are also different social factors. Some of these options may or may not be acceptable to a community. So, in particular, the biogas technology has its own challenges. So I hope the next 2 presentations will touch on that. And the environmental factors as well, because it's you're trying to improve your system, but are you actually improving it? So you've got various different factors to integrate so as to choose the most appropriate option. And that will be it for me. So thank you very much.
Thank you. Thanks, Emma, providing a great overview, I think, of the linkages between water and energy and bringing it back to the land, and I think introducing some of the issues that our other 2 speakers will talk about. So our second speaker is Mike Theodulu. Is the Director of Research and Development in Energia. In this position, he leads a team of researchers and engineers focused on developing products and solutions for the wastewater and biosolids marketplace. From his 15 years of industry experience, Mike has engineered over 50 water and wastewater treatment plants and over 15 new technology innovations for water and wastewater marketplace. Something you may not know about Mike, and I learned this from another colleague of mine, is that apparently he enjoys doing crazy workouts in Uganda at unearthly hours in the morning. So I heard that from a friend who recently traveled with him. So if you can help me welcome Mike.
Yeah, thanks, Kate. The reason why we had to do them at an ungodly hour is because we went with Kate's colleague Corinne, who I don't know if has been in one of these lecture sessions, and she runs a very, very tight ship when it comes to scheduling. And there's only about half an hour in the morning in which you have available to do something for yourself. So it's usually dark out when you're there and you're trying to get your workout in. So I had the pleasure, or I'm still having the pleasure, of being part of the team that's working on the Waste to Wealth project, combined with UNU as well as McGill and Trent University. So go down. The whole premise of the Waste to Wealth project is it's a program in which the UNU had got some seed funding from Grand Challenges Canada to investigate potential solution for water and sanitation issues in a developing country. So the premise of our project was to look at how anaerobic digestion could be used in that facet. So when we look at our vision, the economic and social benefits of biogas generation, solid fuel product, fertilizer, and soil amendment to new livelihoods from wastewater management, it's really a principle about how can we take some of the benefits that we see in wastewater treatment, as well as the utilization of wastewater residues, and apply them in a developing country. the key premises that we base this project on is conserve and protect the environment, improving the water quality and reduce dependency on forests. In a place like Uganda, most of the population relies on fuels such as charcoal, which is taken from actually deforesting the country and is burned for needs of for cooking and for lighting in some cases. So improve quality of life. At the same time, that type of fuel source leads to a bad environment from an air quality inside people's homes or whatnot, as well as it's also usually reliant on the female in the family to collect those types of products and to bring them back to the family to be utilized. Then thirdly is to stimulate economic growth in the country, and then finally look at how that economic growth can finance improved sanitation in the country. I'm going to skip over this slide, but to give you a context of this project, in Uganda, there's very much so a lack of appropriate treatment for human waste, and that is seen statistically can be directly linked to how the morbidity and mortality rates are in that country. I think the average life expectancy in Uganda is 56, and they have a very high infant mortality rate associated as well. The other context, more on the economic side, is how can we take the benefits of wastewater treatment, such as the nutrients which are held in wastewater, the production of biogas, and then the utilization of those to potentially make a more fertile soil, or even offset that said charcoal as a fuel source. So the whole premise of our project is a team from UNU, from the universities, as well as myself, who visited Uganda on a couple of occasions, did first off a fact-finding mission, and then second of all have put together a framework for the country. So typically in Canada, this is just a picture of how wastewater treatment happens, and I don't know if Dan's going to go into more detail about this, but basically, you have a very sophisticated process that has been in place for many years, where you take raw wastewater that comes in from collection systems throughout a city or a town. You have a first off step where you have sedimentation, where solids are settled out of the wastewater here. And then the water portion of that wastewater goes to a step in which it is degraded biologically, such to eliminate organics from the wastewater. Then finally, it goes through further clarification, and then it gets sent back out to in this case Lake Ontario. In the same time, the solids that was settled out of that water goes through a digestion process, and this is anaerobic digestion. So that is in the absence of oxygen, and the bugs that reside in that anaerobic digestion community produce what's called biogas from the digestion of those organics. So the great thing about biogas is it's rich in methane, and that makes it something that's a valuable fuel product. And then the other thing you have left, though, after digestion, is you get a solids residue, and that solids residue has to be dealt with. In Ontario, like here, that is something that's pretty easily dealt with. I don't know if nowadays you don't really see these trucks spreading them, but you generally will see that biosolids that's left after anaerobic digestion spread on crop fields. So, as I was mentioning through that slide, there's three main products of wastewater treatment. One is a clean effluent. So you can see here, this was the raw wastewater. the raw wastewater going into a plant, and then that's the clean effluent that would leave a plant that would go back into here, Lake Ontario, or into a watershed. I probably stole a picture from Dan's presentation, but that's the biogas dome from the Woodward wastewater treatment plant. So that big globe that you see when you drive along the QEW, that's actually full of biogas. And then in the forefront, that's one of the conversion technologies that Dan will mention about how they utilize their biogas. And then lastly, you can see there's an application of biosolids onto farmers' fields. Very rich in nitrogen as well as phosphorus, biosolids generally are. So, but how does that look in Uganda? So, Uganda has a much different approach, and I don't think it's on purpose, to how they deal with wastewater treatment and sanitations. Only about 10% of the populations in urban centers in a country like Uganda have centralized wastewater treatment. That's where they have collection systems as well as treatment systems. And even still, though, the wastewater that is treated in those systems is very poorly managed, and the level of sophistication is inadequate, is too high, for the people that are managing it. And what ends up happening is you get a very dirty effluent that goes out of those plants. And that effluent from the capital city of Uganda in Kampala goes into Victoria Lake. So it does not bode well for the community that's supported from that lake. And then finally, the last picture on the bottom I'd like to show and talk about is a picture to try to capture the sanitation issue that there is in third world countries. So Kate knows about this. We all visited a informal community in Kampala, and these were children that lived in the community, and their main source of entertainment was to play in the refuse that was alongside the river that was at the bottom of this community. And that river was where waste was dumped into, as well as where sometimes water would be taken from for either cleaning purposes or whatnot. So when we try to focus on anaerobic digestion for somewhere like Uganda, we try to make it as simple as possible. So basically taking something that would come from how you would see in your house, in your toilet, and bring that into a digester immediately, and just try to capture what we can from that. And that capture is the biogas itself, and how can that potentially be utilized in a place like Uganda. And then finally, they have a different name for it, but the biosolids that would be left afterwards utilized from a beneficial perspective, either as a fertilizer or potentially as a solid fuel, which I'll talk a little bit more about. I talked a little bit about what our project is. So let's see how the pathways are from a standpoint of how do you get value using anaerobic digestion from waste. So if you take a look at it, it's not just wastewater that you can put into a digester and generate biogas. You can also look at putting crop residues in. You can put food waste. In Hamilton, there is a source separation program where you have a green bin where you put your kitchen scraps in. That can be anaerobically digested, similarly as sludges from wastewater. You can put cow manure in. You can put chicken manure in. All of these things are valuable feeds into a digester. And the byproducts of those is biogas, as we've mentioned much, as well as the bioslurry or the biosolids that come out. Now, when Dan's going to talk, he's going to talk on mass scale, what we do with biogas. But when you take a look at when you look at a country such as Uganda, their main principle, or what they're looking for, is how can I offset the use of my charcoal for cooking, and how can I potentially provide light to my family, because most community or most households do not have electricity in their house. And then in a more larger scale, if there's an opportunity to convert to either electricity or even compress biogas and make that as a fuel source that can be transported around. on the biosolid side, the utilization of that as fertilizer, similar to as we have here, but also potentially in drying that and making that into a solid fuel. What I mean by a solid fuel is that when you take a look at charcoal itself, what they use to cook, it has a calorific value of around 12 to 13,000 BTUs per pound of charcoal. So that means that if you can find something that can offset that need, that energy value, then you can look at diverting people from buying charcoal, burning it in their house, and actually making some internal air pollution. So when we take a look at this bioslurry that we have now, it still has a calorific value to it after it's been digested. And it's around half of what it is about charcoal, but from a standpoint of it's something that is an alternative to that, it's a potential product that could be both sold as well as utilized by a home to reduce their dependency on charcoals or other potential fossil fuels. I'm pretty much on time, but maybe what I'll just describe quickly is that when we did our project there, the last time we went back, we had to present, or we presented various options for the application of anaerobic digestion in their communities, and we looked at it from many different scales. One where we looked at it on an urban scale, so similar to the size or type of scale that Dan's going to talk about in a little while, as well as what could we do in these small informal settlements where you do not have any sort of infrastructure from a waste standpoint, and then as well as what would be done in both institutions or in rural communities. And what was very telling to the audience as well as to the project team is that most of the scenarios that could be incorporated there had a very good economic payback. So it didn't cost very much to implement there, and that the byproducts of the biogas and the solid residue that come out of that would be able to help self-support the initial investment. So the next steps now that we have to this project is to actually put a plan together back to Grand Challenges Canada for what our second stage would be, and that is for a chance to get $1 million to actually implement this framework in Uganda, which I and the rest of the project team are very hopeful that we will get, hopefully in short order, I think in the next 6 to 8 months. And that's kind of a snapshot at looking at something that is a large endeavor in North America, but on a smaller scale, and how it can be done in a very different environment. Okay.
Thanks, Mike. It's been really exciting working with Mike on that project and going to Uganda and seeing some of those anaerobic digestions and how they work in the communities, and particularly where they can work in rural and informal settlements. So thank you for that. Our third speaker is Dan McKinnon, who's the director of Hamilton Water and has been employed by the City of Hamilton for 20 years. Dan has a full portfolio that includes water and wastewater treatment, distribution and collection, meter operations, customer service, environmental laboratory, where's the rest? Environmental monitoring and enforcement, as well as water and wastewater planning and engineering. Very busy guy. Dan lives in Ancaster with his wife and his 2 sons, and he's a proud, lifelong Hamiltonian who never misses an opportunity to advocate for and brag about Hamilton. What you may not know about Dan is that I asked him briefly before, and he said, unlike Emma, his mom is French, and he loves wine and cheese. So a little bit different there. If you could please help me welcome Dan.
Thanks, Kate. Good evening, ladies and gentlemen. I'm very pleased to be here. As Kate says, I'm the director of Hamilton Water. So you might imagine that over this winter I've been a pretty busy guy with frozen water services and broken water mains. So we're going to do our best to make sure that that doesn't translate into a big water increase for you next year. My presentation today is just following up on the previous two speakers, is to talk about some of the, what I would say are some of the cool things that we've been doing down in the Woodward Avenue wastewater treatment plant over the last number of years, and to maybe just kind of share some of the details of those projects and some of the pride that we have in Hamilton, because we view ourselves as a leader both locally and nationally with respect to what we do with solids and biogas. So I have 25 slides here, and Kate's probably going to have to give me the hook at some point, so I'm just going to blister through some of these details that you may or you may not know about Hamilton already. But we service a population of 520,000, and as Mike referred to, we have what's called a conventional activated sludge secondary treatment facility at Woodward Avenue. It can handle about 409 million liters of flow a day, and on peak days it can go to 614 megaliters. Hamilton is unique in that it has a very old sewer system, which means that in the mid-1800s, when they started burying pipe in the ground, it would collect rainwater as well as sanitary flow from the homes in Hamilton. So that creates a lot of unique challenges for us down at the wastewater plant, certainly during wet weather events. So we have that peaking factor where we're allowed to treat 614 megaliters a day. And one thing that I always want to share with groups that I see like this is sometimes you'll hear in the news that we're bypassing raw sewage into the harbor, and the reality is we do that, and we have to do that, because if we don't do that, we're actually breaking the law. So whenever I see flows at the plant to 614 megaliters or more during a day, I have to bypass that to the harbor. That's just the way the rules are. So sometimes you may see that in the news or in the media, and you may not understand that, but it's not a mistake. We didn't forget to hit the red button. We're supposed to do that. So we talk about our solids train as well, that it is anaerobic digestion, and certainly happy for Mike to take that picture of ours and share it with the rest of the world. This is an aerial photograph of the plant. One of the things that's unique about Hamilton's wastewater plant is it's on the same property as our water plant. And sometimes when I say that, I just let that sink in for a minute, and people start to make the conclusion that your wastewater plant and your water plant are on the same property. One of the great benefits we have here in Hamilton is that Red Hill Creek flows. Is this a pointer too? Oh, here it is. So Red Hill Creek flows, where are we here? Flows right along the edge of the plant, right along here. So what happens is the wastewater plant, which is this facility here, actually discharges to Red Hill Creek, where the intake for our water plant is out in the lake. So there's probably about 7 or 8 kilometers difference between the two, so there's never any interference between the two. But one of the great benefits that we have is that it makes our operations very efficient, because everything's in one facility. Cogeneration. Back in 2006, the City of Hamilton undertook a project where we decided to, instead of flaring the methane that's produced through our process into the atmosphere, we started burning it in a cogeneration facility, which is a combined heat and power plant. What this means is that we generate 1.6 megawatts of electricity, and we use the waste heat that's generated from that production of electricity to heat our digesters. Mike talked about digestion of solids material. That has to be done at about 37 degrees centigrade, so you need heat to do that. So we implemented this project about 8 years ago, and we won several awards for it. We're very proud of it. We think at the time we couldn't find another municipal wastewater plant in Canada that was actually doing that. There may have been one, but we couldn't find one. The net benefit to the city was that we signed a 20-year standard offer contract with Ontario Power Authority, and the business case overall, it saves us anywhere from $200,000 to $400,000 a year in natural gas costs, because we're using the waste heat to heat our digesters. And the revenue from the electricity is anywhere between $600,000 and $800,000 a year. So it was about a $1.2 million benefit to the city by implementing this project, and I think we paid it off in about 4 years. So we're very pleased with that project, and it's one of the things that happens in the background so that the residents in Hamilton, we're trying our best to keep your water rates down, and these type of projects are the types of things that we invest in to try to do that. There's a little bit of risk involved, but we try to do our best to analyze that risk ahead of time to make sure that the payback is there. From an environmental perspective, some of the things that are benefits of the project as well is that there's a 6,500 ton reduction in carbon dioxide emissions. There's a reduction of 1.5 million cubic meters of natural gas that we need annually. It's obviously green energy, and this really isn't one of the drivers for a project like this, but it really is starting to place Hamilton at the forefront of this industry for taking chances like this and implementing new technology. So there's Mike's picture. I borrowed it as well. And so You got it off Google, yeah. The picture's in a lot of places, and I think probably the sphere or the globe that's at the plant is one of the most recognizable landmarks in Hamilton. And I think most people think it's full of water, but it is actually full of methane. And that's where we store the methane between the digestion process and when we use it in the cogen. Prior to the cogen, and that's the facility right there. Kind of, you can darn near fit it on the back of a flatbed trailer, the skid-mounted cogen facility. But that's the whole workings of it right there, and it's basically just a big diesel engine that's been converted to burn methane, and it's got a heat recovery system on it as well. So this is just part of the business case around the biogas production and what we're expecting to see. One of the unusual things that's happened in Hamilton, and it's happened in a lot of places across Canada, and certainly in Ontario over the last number of years, we are dictated how we're going to grow by the province of Ontario. So we had to establish what is that going to mean? What is that growth going to mean for us with respect to flows coming to the wastewater plant? So based on that, we can determine how many solids we're going to get out of the wastewater treatment process over the next decade. And we could see by doing the analysis that we were going to have more gas production than we could burn in our cogen facility, because we can only burn about 15,000 cubic meters a day. So we were left with the decision of what we were going to do with that extra gas, because we would have to flare it off into the environment. I won't get too far into the details here, but one of the things that you see on this chart is Hamilton is also what we call a RAP community, and the gentleman standing in the back corner there, Chris McLaughlin, is with the Bay Area Restoration Council. So what this means is that Hamilton has made a commitment to cleaning up Hamilton Harbor. Maybe by a show of hands, who wants to go to my house and have a barbecue with some fish that I caught out of the harbor? So we got a few risk takers here. So Chris is very committed to this, and so is my department and the city as a whole for cleaning up the harbor. So one of the things that we do at the wastewater plant to try to support that goal of delisting it as an area of concern with the International Joint Commission is we are going to be building a tertiary plant, which means that we're going to put in a third level of treatment to the wastewater treatment process. Right now we have 2 levels. It's a secondary plant. We're going to build a tertiary plant. It's kind of expensive. It's going to cost us about $150 million to build. But what it's going to do, it's going to remove one of the biggest contributors of contaminants to the harbor in order to allow us to have it delisted. By virtue of building that tertiary plant, we're going to generate even more methane. So now we know we're going to have more methane in the future to deal with, and we were trying to make a decision about what should we do with the methane. So we came up with a project, and we called it the Biogas Enhancement and Digester Upgrades. One of the other issues that we were struggling with, and we're still working with today, is the biosolids. And Mike referred to that, and you saw the photograph where you spread it on agricultural land. That is the practice that we currently have in Hamilton, although we are having some hiccups with that currently. But that's been the practice that we followed for about the last 16 years, trying to have a beneficial reuse of that material, put it back on the land so that the nitrogen and the phosphorus can be used for agriculture. So but one of the challenges you have with that is the biosolids. The folks who don't like biosolids and may argue against it will talk about things like pathogens and heavy metals that may exist in the biosolids. So one of the things as part of this project that we wanted to do was increase our ability to stabilize the biosolids and to make sure that it was safe to put on land. And then what else are we going to do with all that extra gas? So that was the driver of this project that I'm going to talk about momentarily here. When we were in the midst of planning this, 2008, 2009, the economy went in the tank. I think everybody's aware of that. The federal government came out with a program called the Infrastructure Stimulus Funding Program. So they made money available to municipalities all across the country in order to help stimulate the economy, and you could build roads or bridges or whatever projects you decided to put forward. In Hamilton, we put forward a list of about 140 projects. A lot of them were roads and bridges, but when the government took a look at our list, they liked the water and wastewater projects best of all. So I was kind of in the penalty box there for a little while because of the $180 million that the province and the feds gave to the city of Hamilton in 2009, my division got 130 of it. So we were quite happy about that, but that wasn't going to fix any roads. That was just going to build water and wastewater facilities. So we made really good use of that, and one of the projects out of the 7 that were approved was the biogas project and the digester enhancement. So I won't spend too much time on this. This is just a little detail, and I understand from Kate that this is going to be put online afterwards, so there is more detail here for those folks who might be interested in it. But essentially what we were looking at was we needed to increase the solids retention time that our solids stayed in the digesters to make sure that we were killing more pathogens and we were stabilizing the material to make sure it was safe to put on land. And one of the benefits that you get from putting it in the digesters longer is you keep generating more and more gas. So we knew that we were going to see an increase in gas production, so we had to make a decision about what we were going to do with that. So this is a lot of detail that I'm guessing you won't need, but we'll just roll through it really quick here. But essentially what we did was we made a decision to say, well, we could put in another cogen facility, but we didn't have enough gas to run the other cogen facility. And one of the things that, as municipal bureaucrats, that we're trying to do differently in Hamilton is we're trying to take a business approach to how we do things. So one of the things that we determined at the time of analyzing this project was that there was different opportunities to maybe do something different with the gas. So what we landed on was a gas purification process, and what we're doing with that was, this is some of the analysis that we went through. So essentially what we're doing, instead of putting it in an engine and burning it, what we're doing is we're cleaning it up and we're putting it in the natural gas grid. So the reason we're doing that is we don't know where the economics are going to go over the next 10 or 15 years with respect to this. We have a term for our cogen that's going to operate for a certain amount of time, and then that will end. If natural gas prices go up, well, now we can move more gas over there. So we're trying to play the economics of where's the best place to put the gas, and now we've got more options of how we want to steer the gas. We think that's not typically risks that bureaucrats would take in a municipality, but again, we want to take a different approach here, and we want to be able to respond to the environment that's around us from a business perspective so that we can generate more revenue for the city and reduce as much of our costs as we possibly can. So by virtue of having the purifier, whenever we have to shut the cogen down to do maintenance, now we've got somewhere else we can push all the gas. So this facility's been up and running for about a year and a half. We're not generating the kind of revenue that we'd like to see out of it yet. Natural gas prices are at an all-time low right now. But you may have heard in the newspaper recently that Enbridge has just applied for a 40% increase in natural gas prices. I can just imagine their phones are ringing off the hook. I understand why that happened. It was a very cold winter. They had to buy gas at a premium. But that, to my thinking, is a perfect example of why, as municipal representatives, we need to start thinking differently about how we operate and where are opportunities for us to generate revenues so that we can keep your costs down. I don't think anybody's going to put their hand up and tell me that they want to give us more money than they absolutely have to, and I understand that. But we have to start thinking differently. So I kind of went over these slides pretty quick. Basically, this is part of the analysis that said, when do we push gas to the purifier and when do we let it go through the cogen? And then this is another slide that just talks about, so this is the gas along this line. Everything below this line is what's going through the cogen right now. And as we grow and the community grows and we start to see our flows increase, we're going to have more and more gas going through our purifier that we can put into the natural gas grid. So we're really well positioned now, no matter where the economy takes us. If hydro prices go up or if gas prices go up, what 10 years ago would have been a problem for us is now becoming an opportunity for us because now we can respond to it. So I'm at 13 minutes right on. So with that, I'll conclude it, and happy to answer any questions when the time comes.